Okay, so this is the video over the second half of 3.3, and if you understood 3.3a, which was just basic completing the squares, then this section should not be bad for you at all. Okay, so let's look at example 1. Now, when it says to write this in vertex form, then identify the vertex. Okay, what we're going to do is we are going to complete the square and then kind of move things around at the end. Okay, so think of this for now as 0 equals x squared minus 12x plus 18. Okay, now like yesterday when we wanted to complete the square, we would move the 18 to the other side. Okay, so we're left with negative 18 equals x squared minus 12x. Okay, now, as we had discussed in class, we want to find our c value on the right-hand side of the equation to make this a perfect square. Okay, but if we add it to the right, we have to also add it to the left as well. Okay, so to do that, we're going to put it in the box. Okay, so we have my x squared. Now remember, if we want to cut negative 12x into 2 equal parts, it'd be negative 6x and negative 6x. Okay, we don't know what this is, but by factoring this, we can find it. So if we factor this out, we have an x and an x, and if this is an x, this is a negative 6x, we have minus 6 and minus 6, and then negative 6 times negative 6 is a positive 36. So this positive 36 will go here and here. So we have positive 36 minus 18 equals x squared minus 12x plus 36. So that's what you get when you plug that 36 in on both sides. Now, we want to factor this here, but we've already done the hard work up here. It's just x minus 6 times x minus 6, which is just x minus 6 squared, and that's going to equal, what is that, 18? Okay, now to put this into vertex form, we're just going to move the 18 back over. Okay, so 0 equals x minus 6 squared minus 18, or y equals x minus 6 squared minus 18. This is vertex form. Okay, so our vertex is 6, negative 18. 6, comma, negative 18 is our vertex. All right, I want you to try to do B on your own, so go ahead and pause this, think of what we did for A, try to work through this out, and then we'll go over it when you're done. All right, so hopefully you worked through B on your own, and when you did the box method, you found that 25 was the number we added to both the left and the right, so we'd get 25 minus 24, which is 1, and then x squared minus 10x plus 25 factors into x minus 5 squared. Okay, then when we move the 1 to the other side again, our equation in vertex form would be y equals x minus 5 squared, and then our minus 1 at the end. So our vertex would be our 5, negative 1. Now, I probably should have said this before, but vertex form, ooh, I don't know why that's disappearing. Whoa. Okay, that was really weird. But vertex form is y equals ax minus, I think they used h plus k, and there's a squared here, okay? And your vertex is at h, comma, k. All right, now we've learned various methods of how to solve quadratics. And each one of them are useful in their own case scenario, and some of these are kind of preference as well. But if we go through here, and just what's the quickest, easiest way we could solve this? Okay, so using factoring, square roots, or completing the square. So let's pretend that those are our only 3 options. Okay, if we look at this one would be factoring, because all we have is just our GCF. Okay, so if we pull an x out, I get x plus 7 on the inside. That's going to equal 0. Okay, that would mean when is this equal to 0? Well, when x is 0. And when is this equal to 0? When x is negative 7. Okay, so very easily I can solve that with factor. Okay, this one, because we already have a perfect square on the left, we would just use our square roots method. Okay, same thing here. If we add 225 to both sides, I'm left with x squared equals 225. And then we could also use our square roots method. Okay, now this one, since I have my A and B and my C, it's going to be a little more complicated. So of what's listed up here, does factoring work? No, this one doesn't factor. Okay, so we would use completing the square. Okay, but remember before we do that, we would want to make our A value 1, so we could divide the whole thing by 4, left and right, to just get x squared plus 2x plus 3 equals 0, and go from there. All right, let's look at example 3. It says the height y in feet of a baseball t seconds after it's hit can be modeled by the function, and then it gives us all this here. Okay. Find the maximum height of the baseball is what we're trying to do in part A. Okay, so anytime I don't have a visual, I want to draw one. So I hit it, it goes up, and then it comes down. Okay, now notice, if you recall from what we've done, this is our H0, which is our initial height. So if 3 is our initial height, that means this point right here is 0, 3. Okay, so we want to find the maximum height of the baseball, which would be right here at its vertex. Okay, so I'm going to go ahead and put this in vertex form. So the first thing I want to do is move the 3 over. So it'd be y minus 3 equals negative 16t squared plus 96t. Okay, now remember, from here, I want to add some number to the right and that same number to the left as well. Okay, but also remember that I always wanted my A value to be a 1. Okay, so y minus 3 plus some number is going to equal. So what I'm going to do is I'm going to factor out this negative 16. Okay, and when I do, I get my t squared, and then I get a minus 6t plus whatever that number is. Okay, I'm going to go ahead and put this in the box now. So x squared, now if I separate minus 16 to 2 equal parts, it's minus 3t and minus 3t. And if I factor x minus 3, which means this right here has to be negative 3 times negative 3, which is positive 9. Okay, so I'm going to add positive 9 here. Now, this is where it can get a little confusing. If you think of what I've just done to the right side of the equation, I didn't add a positive 9. I added a negative 16 times a positive 9. Because remember, I factored this out. So if I were to unfactor it out, or if I would distribute this through, this would actually be a negative 144. Okay, so when I do that, I want to add a negative 144 to the left side. Okay, now if I clean this up, I have y minus 147 is going to equal negative 16, and my t squared minus 6t plus 9 factored is just x minus 3 times x minus 3, which is x minus 3 squared. Okay, so to put it in vertex form, I just want to move this 47 back over, so it's going to be y equals negative 16. Sorry, I keep going back and forth between x's and t's. It should be t minus 3 squared, and then I'm going to add the 147 back over. So all I did is I added 147 to both sides. Okay, now from here I can easily get that my vertex is at 3, 147. Okay, so when I'm talking about the height, remember my x value is my time, my y value is my height, so my max height is right here at 147 feet. All right, so if I look at B, it says how long does it take the ball to hit the ground? Okay, so it hits the ground right here. Okay, now notice when I hit the ground, my height is 0. Okay, my y value is 0. So I'm going to plug 0 in. So I'm going to use this equation that I've come up with here, plug 0 in for y. So 0 equals negative 16 t minus 3 squared plus 147. Okay, now I'm going to go ahead and solve this. So minus 147 minus 147. So negative 147 equals negative 16 t minus 3 squared. Okay, divide both sides by negative 16. If I put that in my calculator, I get 9.1875 equals t minus 3 squared. Okay, now I square root both sides. So I'm left with roughly plus or minus 3.03 equals t minus 3. Okay, and then if I add 3 to both sides, add 3. Okay, so notice on one I get negative 0.03 is my answer. Guys, I'm not going to have a negative time, so that doesn't matter. So it's just going to be 3.03 plus 3, which is approximately 6.03 seconds. That's when it's going to hit the ground. All right, let's look at example 4 now. Now we all know that the area of a triangle is 1/2 times base times height. Okay, so nothing's changed. My area of my triangle is still 1/2 my base times height. Okay, so I know my area is 30. So I'm going to put 30 equals 1/2. My base is x plus 2. And my height is 3x. All right, now if I kind of factor out this 3, I get 30 equals 3 over 2, and this is going to be x plus 2 times x. So 30 equals 3 over 2 x squared plus 2x. Okay, now if I want to complete the square, okay, I'm going to put this in a box. Remember, I'm going to add something here, but I have to add that same thing here. So x squared, if I divide 2x equally among two spots, it'd just be an x and an x. So I have an x, 1, 1. 1 times 1 is 1. So add a 1 here, add a 1 here. Nope, just joking. Remember, I didn't add a 1. I added a 3/2 times 1, so I really added a 3/2 or 1.5. So 31.5 is going to equal 3/2. And then if I factor this out here, it'd be x plus 1 squared. Okay, now I just solve. So I'm going to multiply both sides by 2 to get rid of the denominator. That makes my life a little easier because I get rid of the fraction. So that's 31.5 times 2 is 63 equals 3 times x plus 1 squared. So divide both sides by 3. I get, my brain is dead today, guys. 21 equals x plus 1 squared. Okay, take the square root of both sides. I get plus or minus square root of 21 equals x plus 1. Now, guys, I can't have a negative side length. Okay, so I'm going to forget about this minus. And to solve, I just do minus 1 minus 1. So my x is going to be negative 1 plus the square root of 21. And if you want to put that into a decimal, that's roughly 3.58. That would be the value of my x.